This is a quick video on the relationship between voltage, current and resistance for an electrical circuit. So what we're going to do is just take a look at voltage, current and resistance. And the quickest way of thinking about these immediately is thinking as voltage as the push, current as a flow of charge, and resistance as the opposition to that flow of charge. So the voltage pushes the current, and the resistance tries to oppose any push of that current. Before we go further though, there's an analogy, and the analogy is with bike chains. So if we look at the bike chain is one single unit that's slightly movable, and in order to make that bike chain rotate or progress around, you need to pedal on the pedals of the bicycle. In other words, you need to push on the pedals for the chain to flow around along its route. So the push is the pedals and the chain represents the flow of charge. In other words, the voltage is you pedaling and the current is the flow of charge. What's important to note with this analogy is that a bike chain is made up of many links that are all stuck together. So the speed of that bike chain at every point is the same. So the speed of the bike chain at the top of the bike chain will be the speed of the bike chain at the bottom of the bike chain. And that's the same for electrical circuits. The voltage pushes the current, but as the current rotates around like a bike chain, the speed of the current at all points in the circuit is the same. Okay, so let's have a quick look at voltage and current again, but in this case we'll look at an applet. This is a PHET applet. So I'm going to set up a circuit like this. At the top we have a battery, that's the orange and black object. We have a bulb towards the middle at the bottom, and we have a switch towards the bottom right. And then you have these brown wires connecting all of them with these circles with a minus in them in the wires. Now the circles, the blue circles with the minus in them, are electrical charges, and because we have the charges connected up to a battery, the battery, which has a voltage, will push the current around the circuit. So what I want you to note here is the push comes from the battery and the push is the voltage. And the second thing that I want you to note here is that the voltage pushes the current around the circuit and the current around the circuit stays the same at all points. So let's have a look at the applet. It's this one we want. So if I close the switch, we'll see that the speed of the current, or the speed of the charge there, even through the bulb itself, and there is all the same. So the current moving around the circuit travels at the same speed, or the charge moving around the circuit travels at the same speed, so the current is the same. Now obviously, if you pedal harder, the bike chain will move faster. So the pedal in this case, or the push, comes from the battery. If I click on the battery there, its voltage is set to 9 volts. So if I increase the voltage, if I increase the push, you can see that the flow of current increases as well. But yet again, the speed on the left and the right, and even through the battery, or even through the bulb itself, is exactly the same. We'll go once more. If I increase the voltage again, I'm increasing the push, and increasing the push is like pedaling faster on that bike chain, so the chain itself, which is the charges that are connected, increase in speed. Okay, let's move on to the next bit. So the final part here is that you need to understand that while the voltage pushes the current around the circuit, the current carries energy as it flows. And it's that energy that it carries that results in the light bulb being lit. Okay, how does resistance come into this? So resistance is the opposition to the flow of the charge. And we'll go back to our bike chain analogy again. So if you were pedaling the bike and the chain was flowing around, one way that you would decrease the speed at which the bike chain is rotating is to put your hand gently on the bike chain, and while you would get a burn, the bike chain would slow down. So you are exerting an opposition to the rotation of the bike chain just by gently trying to grab it. Now, that's the exact same thing that happens with resistance. So the resistance is like something gently grabbing the bike chain, and that opposes the bike chain rotating around. Okay, so we'll go back to PHET in a moment. And you need to understand that the resistance will slow the flow of electric charge. Now, if you look at the diagram up at the top, we have the battery, that's at the top of the circuit diagram. We have the bulb on the bottom right-hand corner. And then there is this kind of cylindrical thing there with brown, black, and yellow stripes on it that represents the resistor in this case. And the resistor will slow down the flow of charge. So just think about you're placing your hand lightly on the bike chain, and that will try to prevent the bike chain from going around at full speed. All right, so what that means is the resistance in the circuit will decrease the current. Now, there is one other point that I want to mention before we go to the PHET applet, and that is the order of those components doesn't matter. So if I was to swap the resistor and the bulb, it would have the exact same effect. And that would be similar to you holding one part of the bike chain or gently holding another part of the bike chain. It would have the same effect to slow down the current or slow down the bike chain rotating. All right, so let's have a look. So this is the one. I close that. We can see here that the current is flowing at a certain speed. So if I was to disconnect the resistor and take it out and connect it up, we can now see that the bulb lights kind of brightly. There's a flow of charge there, and just to show you that it's actually working as it should. So the current is like this. That's 0.9 amps there. That measures how quickly the charges are flowing. If I was to reinsert in this component, the current is decreased. So the resistor behaves as if you're gently grabbing the bike chain, and as a result the flow of current decreases. Now, I did say that the orientation or the position of those doesn't matter. So if I close this and check the current again, we can see there that it's 0.45 amps. So it doesn't matter if you grab the bike chain on that side or that side, it affects all of the current flowing around the circuit. All right, so let's summarize. There are 4 points. 1, voltage pushes the current around the circuit. 2, current is a flow of charge. And we've already stated that the charge flows at the same speed around the circuit. As the current flows, it carries energy, and a resistance will decrease the current in the circuit because it decreases how quickly those charges are flowing.